Hello, my name is Roy Jiang. I'm the Technical Marketing Engineer from Cisco System, covering the ASR9K BNG. So today, I would like to demonstrate how to do single subscriber multi-session hierarchical QoS. So this is the use case. So for a certain subscriber, there may be multiple user devices behind a bridged RG. They will create sessions on the BNG respectively. But some service provider may want to apply a hierarchical QoS to the subscriber, giving an aggregated shaper to all of the traffics from/to that subscriber, and the session-based QoS to each of the user devices respectively. So to realize this, the Cisco ASR9K BNG has a feature called SPI. SPI stands for the Share Policy Instance. With this feature, you can have multiple sessions belong to a common SPI to share the fate in terms of QoS. In other words, the QoS applied to the multiple sessions which belong to a common SPI does traffic conditioning to the aggregated traffic for those sessions. The SPI could be defined in the reduced user profile, and you can also define it locally with the dynamic template. So in my demonstration, I will show you how to define it in the reduced server, and when the session gets up, those attributes will be downloaded from the reduced server and applied to the sessions. And the SPI works for both ingress and egress QoS. So in this demonstration, I will show you for both ingress and egress, but we are focused on the egress hierarchical QoS. So this is an example. I have one subscriber called user 1. This user has 3 user devices, named device 1, device 2, and device 3, behind the bridged residential gateway. Their PPPoE usernames are user 1 device 1 at S99, user 1 device 2, and user 1 device 3, respectively. So each of these user devices will try to create a PPPoE session on the ASR9K BNG. The BNG will treat them as separate sessions and do authentication, authorization for them respectively, and will apply the QoS, ACL, and the other features to those sessions respectively. So for egress traffic, let's focus on egress hierarchical QoS. I'd like to give a 10 megabit shaper to the subscriber as a whole with some hierarchical scheduling. So for device 1, put it to priority queue with a rate limit of 5 megabit. For device 2, I would like to shape it to 6 megabit. But when the congestion happens among the devices for this subscriber, I would like to give it a weight of 2 on the remaining bandwidth. So the remaining bandwidth means the 10 megabit deduce the actual bandwidth consumed by the PQ traffic. So for device 3, I would like to shape it to 10 megabit. But when the congestion happens among the devices for this subscriber, I will give it a weight of 4, which is double of the device 2 on the remaining bandwidth allocation. And for ingress is not all focus, but you can still do the 2-level hierarchical QoS with policing only for the BNG session. So here I would like to give a 5 megabits policy to the subscriber as a whole with different policy for different devices. For example, here I would like to have a 2 megabit policy for device 1, 2 megabits for device 2, and 4 megabits for device 3. And this is the topology and the traffic. So here you can see this is the ASR9K BNG. I have a sub interface to nested sessions. And for this particular subscriber, I have a bridged CPE for user 1. Behind this CPE, I have device 1, device 2, and device 3. Each device has its unique PPPoE username. So I have the user profile for those 3 devices, for those 3 usernames in my radio server. I will give you the detail of the user profiles in the radio server for those devices. So each device will have its username and the unique CVLAN. So device 1 have CVLAN 1, device 2 have CVLAN 2, and device 3 have CVLAN 3. So this is a chunk between the bridged CPE and the PON. And the PON will add the SVLAN, right? So the double tagged traffic will arrive at the BNG and the session will be created. Here 3 sessions will be created, right? And after that I will generate 5 megabits traffic, downstream traffic, using XCR for each of the devices. So totally there are 15 megabits traffic. Under this sub-interface, you may have multiple users or multiple subscribers. That's okay. But here let's focus on this particular user or this particular subscriber. So here I will have a scheduler on the parent level for this user with a shaper of 10 megabits. And I will put the red traffic, which is the traffic to device 1, into a PQ with 5 megabits rate limit. And for device 2, shape to 4 megabits, and with bandwidth remain ratio 2. For device 3, shape to 6 megabits with bandwidth remain ratio, this should be 4. So let's go to the ASR9K. So you will see this is the terminal window to the ASR9K BNG. First, let's go to the access interface. So this is my access interface. Here, I have a control policy named S99 CP all-in-one. It doesn't matter. This is not the focus of this demonstration, right? And here is the encapsulation. This is a configuration for the ambiguous VLAN, which means all of the sessions coming with SVLAN 90 and any inner VLAN or CVLAN will be served by these sub-interfaces. So this sub-interface will serve thousands of sessions if you want. Okay, I have the PPP enabled. So in this demo, we will bring up the PPP session. Let's go to the control policy. So what you need to know is the basic logic of this control policy. When the session starts, right, the BNG will check if this is a DHCP session or the PPP session. So if this is a PPP session, which means there's a PIDI coming, we will activate a dynamic template. So in this dynamic template, we just say, hey, do PEP for this session. That's all. Okay. Then when the session activate event happen, for PPP session, we just do authentication and send the access request to a particular radio server. That's all. Okay. So let's go to the radio server. You will see the user profile in the radio server. It's quite easy. So let me first stop the radios. So this is a free radio server running on a Ubuntu server. So if we go to the radio server user configuration file, here I have a user profile for user 1-device1 at S99. The critical information here is there's a Cisco AV pair, which is a Cisco vendor specific attribute subcode 1 to specify the ingress and the egress QoS. So this line we say the subscriber policy in, which is ingress QoS, equal this string. This string is the name of the policy map you defined locally on the BNG, with the keyword shared policy instance and the name of the shared policy instance. Here we will give a name of user 1. This is just a string. Right. So for egress, similar thing. We have a name of the egress QoS policy map and with the shared policy instance. So here for this particular user, I have a username for user 1 device 1 and the user 1 device 2 and user 1 device 3. So in each of these user profile, you will see this same AV pair, and all of them have the shared policy instance named user 1. So in this way, you can have these 3 sessions to share the same ingress and egress QoS. Okay, there's some other attribute. For example, you can specify the accounting. So with this line, the BNG will send the accounting message to this radio server and the accounting interval. And you will see some other AV pair. For example, for the device 1, I would like to apply a output ACL. And for another device, say device 2, I would like to apply an ingress or input ACL. So you can have different features applied to different sessions. And of course, you also need to specify the unnumbered loopback. And there's some other things I want to mention here is these two. So if you want to identify, if you want to indicate the radio server or billing system, which subscriber this session belongs to, then you can use this Cisco AV pair. The equal string 1, I say user 1, which is the name of the user, right? So for device 1, device 2, and device 3, all of them have the equal string 1 user 1. This is a customized string, right? You can put any string here into this AV pair. And I have another Cisco AV pair called equal string -2. I use this one to indicate the device name. Here, for device 2, I put the stream of device 2 here. For device 1, I put the stream device 1 here. So those information or those attributes will be included in the accounting start, accounting stop, and accounting interim. So when your radio server gets accounting information, you can tell this accounting message is for user 1 device 1, or user 1 device 2, or user 1 device 3. Okay. So let's quit from the radios. Then let's start the radio server. So let me do okay, the radio server is running. Okay, so here, this is my Xia. This is my Xia. So here I created 3 sessions with the user 1 device 1, user 1 device 2, and user 1 device 3 to simulate those 3 devices behind the bridged SPI. So you will see they come with the common outer VLAN and different inner VLAN or C VLAN, right? So that we can do classification based on the C VLAN. Remember in the user profile we have the Cisco AE pair to specify the name of the QoS for the session. You need to locally define the content of the QoS. So here let me show you the policy map configuration. So this is the ingress QoS. It's a 2-level hierarchical QoS. This is the parent level, right? We say we would like to polish the traffic to 5 megabits, and there's a hierarchical QoS attached. So if you do show run policy map, you will see here. We say for device 1, I would like to polish it to 2 megabits. Device 2 and device 3. Okay. So for egress, we have similar configuration, but the difference is we're doing shaping for the egress traffic, right? So I would like to shape the aggregate traffic to 10 megabits. These 10 megabits shape apply to all of the traffic to those 3 devices. And you can see here I have a tried level QoS attached, so I can do this is the content of the tried level QoS. For device 1, I would like to put this to priority queue level 1 and with a policy rate of 5 megabits. Right. For device 2, I would like to shape this to 6 megabits, and for device 3, it's 10 megabits, which means when you have only traffic to device 1, those traffic will not exceed 5 megabits. If you only have traffic to device 3, you can touch the limit of 10 megabits, which is also the limit of the parent level shaper, right? But if you have only traffic to device 2, those traffic will be shaped to 6 megabits. Although for this user, the traffic limit for egress direction is 10 megabits. Okay, but if in the case you have traffic for device 1, device 2, and device 3, the traffic for device 1 will be put into the PQ and with a limit of 5 megabits. And the remaining bandwidth will be allocated to the device 2 and device 3. with the ratio of 2 versus 4. So which means when the congestion happens, device 3 will got double bandwidth against the device 2. And you may want to check the configuration for the class map. So here, I do the classification using the inner VLAN. Of course, you can define your class map based on the DHCP or IPP or COS. Now, let me bring up the session. Now you can see I have 3 sessions. Those are PPP session. If you use the command line show subscriber session or detail internal, you will see the more detailed information about this session. Here, you can see the radius attribute downloaded from the radius server upon the authentication. Here, this is the name of the QoS and the share policy instance keyword and the name of the SPI. If we jump to the second one, second device is the same. Right? The third one, the same. Okay. If you want to check the definition of the QoS applied to a particular session, you can use this command show policy map type apply interface and just copy paste the name of the session interface here. So this is for this particular session. You can see for ingress we have the hierarchical QoS, and for egress we have another hierarchical QoS. If you check the QoS for another session, it's the same. Because they all downloaded the same attribute for the QoS, right? So if you want to see the counter for the session QoS, you just remove the keyword apply, and you can check the counters for different class and the parent level, child level. Currently I have no traffic passing, so now let me try to generate the traffic. So here you can see I have 6 flows, right? 3 for upstream and 3 for downstream. So this is for the upstream from the IP address 10.99 to 161. This is upstream, and those 3 are downstream. Okay. Let me try to bring up this. Let me try to generate the traffic. And I would like to show you the result of the QoS. Okay, here we go. Let's see the received rate. So I have 3 sessions, right? Remember the configuration of all egress QoS? Let's check this. So firstly, the aggregate traffic for the subscriber, all of the traffic to those 3 devices should not exceed 10 megabits. And then for each device, let's check this. For device 1, it will be in PQ, and the policy rate is 5 megabits. Let's check this. So here the sending rate is 5 megabits for each traffic, for each device, right? So this should be the device 1. There's almost no packet drop. Because this is PQ, right? You need to guarantee the bandwidth for the priority queue. And for device 2, we have a shaper of 6 megabits. For device 3, we have a shaper for 10 megabits. But the real traffic will not touch this shaper. And you will see the congestion among the traffic to device 1, device 2, and device 3. Right? So totally I have 10 megabits for those 3 devices. 5 megabits are guaranteed for device 1. So there are 5 megabits as the remaining bandwidth. And I allocate this bandwidth to device 2 and the device 3 at the ratio of 2 versus 4. So the device 3 got double bandwidth against the device 2. Now let me stop the traffic to the device 1. At this moment I have only the traffic to device 2 and device 3. Right, you can see this. For the traffic to device 2 got 5 megabits and traffic to device 3 got also 5 megabits. There's no packet drop because none of them touch the bandwidth limit set by the shaper for this particular class.